What's up everyone, and welcome to the tutorial about our virtual reality template. Today I'm going to go through everything in our virtual reality template so you can understand it, so you can know how it's working and basically be one step closer to your game. So open your Unreal Engine. First thing we have to do is to create our project. Go ahead and click on Games, choose Virtual Reality, name your project, and then click Create. So once we've loaded in, the first thing we should see is that our player start is located right here. Player start is basically what it's saying it is. It's an actor that can be placed in the world, and the player will be spawned in this place. And to spawn our player, we need our game mode. So game mode defines the game set of rules. So if you go ahead in your content folder and you look for your game mode, it's located here. We're going to see here a game set of rules, and the most important here is going to be default pawn class. So it's our VRPawn. It means that instead of this player start, when we click our VR preview, we'll possess the VRPawn. And just to make sure, go ahead to your edit, project settings, and if you type the game mode here, you will also see that our default game mode is our VR game mode, the one that we have seen before. And the same way, default pawn class here is our VRPawn. Once we start our VR preview and start our game, we are possessing our VRPawn. Let's go ahead and find this VRPawn. So to locate this pawn, we have to go to our VR template folder. We have to go to our blueprints, and here we'll see our VRPawn. So double click on it, you can expand it like this. And as you can see here, there's a lot of code, so don't get scary, we're going to go slowly. So first thing, let's go to our viewport. Everything we have here is the child of our VR origin. So our VR origin is a root component of our actor, and it is used as the reference point for the actor's location in the world. And our camera is the child of this. So now, once this thing's in your head, let's go to our event graph, and here in our event begin play, that's where the game starts. We are checking if our headset is enabled. It means that we are actually wearing our VR headset. And in case it's true, we are setting the tracking origin. So this function sets your real world height and converts it to our virtual space. So let's go ahead and click here, and as you can see, you will see three options: floor level, eye level, and stage. So generally speaking, our floor is responsible for setting places at origin at floor level, which means that the virtual floor will align with the physical floor in real world. And eye level is mostly used for our sitting or standing experience, where the user doesn't need to move around much and the application does not require calibration to the physical space that user is in. Stage configures the tracking space such that the origin is at the center of the play area, which is usually a defined space in which the user can move around physically. So between those three, for instance, if you're developing a game where the player needs to walk around a virtual room and interact with objects at a realistic scale, you would typically choose stage. It's the last one. If you're creating an experience where the player is piloting a vehicle and the sitting position is important, you will choose the eye level. Floor level is basically when you want your VR experience to have a reference point that is the actual floor in the real world. This is important for where the player is expected to walk around, stand, or have any interactions that are grounded. So once we choose eye level, floor level, or stage, it's going to count our real world height based on our floor. So whether you choose those three, as I recently said, in our viewport, we have our VR origin. So if you choose your eye level, for instance, at the event begin play, once you run your VR preview, right, what's going to happen is that having our eye level set up here, the camera is going to replicate your real life height. If your real life is 180 centimeters, it's going to be like this. So in our viewport, your actual height will go to 180 centimeters. Okay, hope that was clear. Afterwards, we are executing console command. You can go ahead and read all the information here, but speaking in easy terms, it refers to the number of pixels used per unit of an image displayed within the VR headset. So if you have higher pixel density, you increase the resolution of the rendered image inside the VR headset. So that's basically what it's responsible for. Okay, let's go back to our viewport. And the next thing we can see is that we have our motion controller left grip and motion controller right grip. They're right here. I'll highlight them. So these are basically our controllers. So our motion controller left grip and motion controller right grip, so they're real world replication of where our controllers are. So your headset has cameras that actually tracks the position of your controllers. And this information gets to those motion controllers left grip and motion controller right grip. And as you can see, we have two skeletal meshes right here. Those are actually our hands that we see in our VR preview. So hand right is the child of motion controller right grip, and hand left is the child of motion controller left grip. It means that the hand left and hand right skeletal meshes will inherit the movement of its parent, of its motion controller grip. So you have your motion controller, it's invisible, and hand is just attached to it. And while your camera tracks the controllers in real world, it also gives the same movement to our hand right and hand left. That's basically how you see your hands in VR preview. So let's go ahead and I will show you what I mean. And before that, just make sure you have stage set up. So let's go ahead in our game. Yeah, I might be too short because I'm sitting right now. And as you can see now, I have my hands and they are not motion controllers. They're children of motion controllers. So motion controllers are invisible and hands are just attached to them. And afterwards, there is also an XRDeviceVisualization left and right. Those are basically supposed to be the meshes of your controllers if you want to have ones. And afterwards, we have our hand-mounted display mesh. So this is just a display mesh that other player may see in your game, and it will be seen from someone else's perspective, but it will not be seen from your perspective. So it's just for the look. So let's go ahead and collapse the things we have covered so far, and all we are left with is our motion controller right aim, left aim, and teleport trace Niagara system. As you remember, we had our motion controller left grip, so that's our motion controller in real world, and the same way we have our motion controller right aim. So it also replicates the real world position of your motion controller. And as a child, it has widget interaction right. So this is used for interacting with widget. So if you go ahead in your details panel, having the widget interaction right selected, and you type here, show debug, enable it here, and also make sure you enable it on widget interaction left, like this, and you jump into your VR game, you will see that we have now two rays pointing from our hand. Like this. And those rays are created to interact with widgets or from menus with buttons from every UI element you have in your game. But by default, they're just disabled because we don't want to see them all the time. So let's go ahead and switch them back. So if we go to our widget interaction right, we'll see our interaction that we have virtual user index, pointer index, and interaction distance. So the main difference between widget interaction right and widget interaction left is that their pointer indexes are different. This is used for interacting with buttons using two hands, because if you set both of them to 0, so pointer index will be set to 0, you'll be able to interact with your right or left hand only. So that's why one of them should have pointer index 1 and another one 0. For interaction distance, I think it's pretty obvious what it does. It's basically the length of your ray. And finally, we have our trace channel. Both of them have the same trace channel called 3D widget, and it will basically interact with our 3D widgets. And the final thing we have is our teleport trace Niagara system. So that's our Niagara system that is used for teleportation. That's the only movement we have in our game. So that's how it looks like. I'm not going into details how to do this, but just know that this Niagara system is used for teleportation. Our Niagara system is actually showing, and the place where we want to jump is also showing. So once we are familiar with our VRPawn and what's inside of here, we can go ahead to our event graph. So that's where all the code is, and that's where we're responsible for our input actions, everything. So now, after execute console command, we can see that we have our add mapping context. The mapping context has been released recently to our Unreal Engine. If you go to your project settings and to your input, you will see this. Access and action mappings are now deprecated. Please use enhanced input actions. So this new enhanced input actions is much better, and it might seem to be hard to understand, but I'll go through it. So before actually explaining what is happening here, I will go ahead and tell you about input mapping context. So go ahead to our VR template. Go ahead to our VR template folder, and after, click on your input. We have IMC default, IMC hands, IMC menu, and so on. So IMC stands for input mapping context. So if you double click on it, you will see the mappings, and you can click on this arrow and expand the list. IA move, IA turn, grab left, grab right, and so on. So the IA stands for input action. That's also a separate element we have to create. So again, go back to our VR template, and as you can see here, we have folder called actions. Double click on it, and here we have a bunch of actions. So just go back to our IMC default, and the first action we have here is IA move. So let's go ahead and open it. IA move. It's right here. So the only thing that we are interested in here is our value type. So it's usually Axis 1D float, digital, Axis 2D, and Axis 3D. If you choose digital, it will only track when the button is pressed or no. Axis 1D, it will output you the float value on how hard your button is pressed or how far your button is pressed, but only in one axis. When you have Axis 2D, it will track how hard the button is pressed in different directions. And the same for our 3D, but in 3 directions. So once we're done with this, we're going to head to our IMC default. Here, how those mappings were added is that the plus icon was pressed, and here, there are all input actions as we have created before. So I'll just delete what I've just done. And let's actually go ahead and open one input action. And as you'll see here, we'll have all the mappings that are responsible for this input action. So for our IA move, for our movement, I have thumbstick Y-axis. It means that it's my thumbstick on right controller, and it's responsible for y-axis of the thumbstick. And the same way we have for our mixed reality, for our wipe, and for our valve index. And if you expand all of those arrows, you will see that for every input action, we assign the keys here. So that was just a brief introduction to input mapping context. And going back to our VRPawn, the first thing we can see in here is getting our player controller. If you remember, I explained to you about Gamemode, that the player start is possessed by VRPawn. So when we press our VR preview, we become a VRPawn. So get player controller actually gets what is possessed, meaning it gets the VRPawn. And afterwards, it's accessing its enhanced input local player subsystem and adds a mapping context. And it adds IMC default. So IMC default, it adds all of those inputs we have right here. And afterwards, it's doing the same, but with IMC hands. So default mapping context has only move, turn, grab left, grab right, toggle left, toggle right. That's for upper menu. And if you go to your another input mapping context, it's our hands, you will see another actions. Point left, thumb up, grasp left, and index scroll. So in default VR template, there are two mapping contexts added. The one for the hands and default movement. So to cover it all up, our event begin play sets track in origin sends our pixel resolution and our image that we see through the headset, and then adds our inputs to our pawn. And afterwards, all the code you're going to see here is responsible for our input actions. So for instance, our IMC default has IA move. And since it has been added to our VRPawn right here in IMC default, we can go ahead and write IA move. And we'll have access to this mapping. And as you remember, IA move has axis 1D float, means that we'll see our action value. And this action value will be 0 if we are not pressing the button, and will be 1 if we fully press the button. So here we have our input action turn. It's responsible for our turn. So if I jump right into the VR preview, and I'll show you how this turn looks, it looks like that. The way the snap turn works is that you can double click on this function and see all of the nodes here. I'm not going into details because the tutorial will take too much. So next input action is our IA move. That's how we teleport. You can also go ahead and see the details here. Then I will skip 2 comments about grabbing because I'm going to talk about them later. They need a lot of attention. So afterwards we have our toggle left menu. So this is basically when you are toggling your menu. It is using the widget. If I press my B on my Oculus 3 controller, you will see that our menu pops up and we can restart our level like that. And if you're wondering where this menu comes from, it's in our VR template, it's in our blueprints, and here you can see your menu. So if you double click on it, there's a lot of code and it will take me hours to explain this. And then we have our animations of our hands. So let's talk about the animations now. So as you can see here, there are values for our left hand grasp left, hand index scroll left. Those are all the input actions that were created in our input mapping context in this one, IMC hands. So all actions we have for our hand is grasp, index scroll, point left, and thumb up. So let's go ahead and I will show you what of those input actions do. So our grasp, this is the grasp action. Then we have index curl. This is our curling the index like that. Then we have our IA hand point left. This action is interesting because as you can see now, my finger is moving a little bit. So my controller actually detects when I just touch the button. So that's what causes this little movement. And if I just touch the button, note, I'm not pressing the button, my thumb moves. Now let's actually go ahead and see how the smooth animation is applied. Remember, I've explained to you about action value of how hard the button is pressed. I will go ahead and print this value. Make note that our trigger is played every frame. So if I jump to the game right now, and on your top left corner, I start pressing the button, as you can see, when I'm pressing, I'm getting the value from 0 to 1. And just have a look at my hand. So if I'm not doing anything, it's idle state, the value is around 0. And if I go more, the value changes to 1. So that's our action value. And we can see those variables right here. If you actually go to your hand right, or hand left, doesn't matter, you may notice that they are using their animation class right here. And this animation class is called ABP Mannequin XR. Let's go ahead and click this button. It will show us where this animation blueprint is located. And it's right here in our Mannequin XR meshes. Let's double click on this. And what I would suggest you doing is to split this into 2 screens, like this. So what is happening here? So for all the actions that are responsible for our left hand, point left, thumb up left, curl left, grasp left, we're getting our hand left. It means that we're getting this hand. And we're trying to get its animation instance. So it's this variable right here. And afterwards, we check if this variable is our ABP Mannequin XR. We need to access this animation blueprint. And afterwards, we're getting its variable you can see it's dragged from here, pose alpha grasp. And switching to our animation blueprint, we can notice that this variable is here, pose alpha grasp. And currently it's located here. So what do we have right now is we have our idle animation for our hand. You can see it's idle animation. And we have our grasp right, this animation right here. And we are using our blend node. So blend node blends two animations, A and B, based on the value alpha. And in our case, our value alpha, and in our case, our pose alpha is 0 by default, like this. So just referencing that our value is changing from 0 to 1, it's changing dynamically in our animation blueprint, making our pose alpha grasp from 0 to 1. And as you can see here, our animation actually grasps. The same way we're having our index curl left. So we're setting now the variable pose alpha index curl. That's this variable right here, and it's right here. So here's our index curl animation. But now we're using layered blend per bone. So what this node does is that it actually, as you can see here, has a bone. So this node applies this animation based on our alpha value, limited by the bone showed here. So let me explain. All of those animations we have before is getting blended with our index curl right. But if we go to our index curl right, make sure you remember the name of this bone, index metacarpal R. We locate this bone in our skeleton, it's this one. So it means that all the animation that is blended right here is applied after this bone. So everything else except for this bone and its child, all of those bones right here, are not touched. So if you use layered blend per bone with this bone, the animation will only be applied to this bone and its children. So all of those following bones, only to our index finger. So that's what our layered blend per bone does. And the same way happens here. So we are blending our point right and sum up with specific bones listed right here. And those are other two input actions for our hand point left and thumb up left. They're having the same logic. And once we release our button, means cancelled or completed, we are setting our pose alpha grasp 0 explicitly. Because if we don't do this, our value will remain still like 0.02, and because of that our hand will not be completely open. So we need to set it explicitly here. And afterwards we're just using a mirror to mirror our animation from our left hand to right hand, and we are getting a result. That's our final animation. Okay, I hope you got everything I have said right now. If you haven't got, please let me know the question in the comment. I'll try to answer. Or you can also go to Discord server. There you'll get your question answered in details. And now is the sweetest part. It's our IA grab right and IA grab left. So as you can see here, for those grabs, we're using now our grab component because we have nearest component here. So what I would suggest you doing is, for better understanding, go ahead to your content and look for grab component. You'll see this here. Double click on it. Let's make a side screen so we could follow two things at the same time. So once we grab, it means that we have started grabbing. We're getting our motion controller left grip. That's this one right here. And we're getting grab component near motion controller. So let's double click on this function. Remember, our input is our motion controller left grip for our left hand. That's where our real life motion controller is located. And we're using the sequence. First of all, we're executing Zen 0, and then we're going to Zen 1. So let's go for Zen 0. So as you can see here, we're getting our motion controller, and in this case, it's our left world location. And we're setting it to the variable. And we're using our sphere trace for objects. So what does sphere trace do? I can actually go ahead and draw debug type 2 for duration. And I go ahead in my game and I try to grab something. And as you can see, there are spheres appearing on my hand. So this is the region we can get some objects grabbed. And here is our grab radius from grip position. So that's the radius of those spheres you have just seen. And afterwards, we have our object types. So this sphere reacts only to object types of type physics body. So maybe you've tried, or no, you can grab your cube in your level. And let's actually go ahead to its blueprint. And as you can see, our static mesh's object type is physics body. So that's why you can grab your cube. So if something in our level overlaps with this sphere you've just seen, and this something has object type set to physics body, our return value from here will be true. So it means the hit will be a valid hit. Afterwards, we're breaking the hit result. It's a long things here. We're getting the information about our hit result. So this will be our object, and we're getting the actor we have just hit. So we'll get our small cube, whole small cube here. And we're getting components by class. So we're getting grab components in this grabbable cube, but we have only one. And this function right here, you see, it looks for the closest grab component. So if your cube has a couple of grab components, it will look for the closest one. So here, it looks for the nearest grab component. So this function right here looks for nearest grab component, and as a result it sets our local nearest grab component distance and returns our local nearest grab component. So in terms of our cube, we're getting our grab component. It's this one right here. And as I've said earlier, we're returning this local nearest grab component from then one pin. Afterwards, we are checking if our nearest grab component is valid, because we want to grab if it's valid, because if we haven't got any grab components, we don't want to do anything with that. After we have accessed our grab component, we are calling its tryGrab function, as you can see here, and we are passing our motion controller left grab reference. So let's go ahead and open our tryGrab function, and in our tryGrab function, we're going through the sequence again. So first we're performing our then 0. So now we have our grab type. So our grab type has 4 different values: none, free, snap, and custom. The ones that we are interested in are free and snap. The first thing we're doing in our free and snap, we're setting our primitive component physics. So let's go ahead and see what it's doing. What it does here is that, as I've recently said, it gets its parent, means static mesh, and sets simulate physics to false, because we have passed false here. It means that our static mesh in our cube doesn't perform any physics, so it actually can grab and move it around. Afterwards, what we are doing is that the motion controller reference we have passed right here, it's our motion controller left. We are attaching parent to motion controller. It means that we're getting our cube's grab component parent, means it's static mesh, and we are attaching it to our motion controller. And that's it for this function. And afterwards, we are just saying our grab component that we're holding an item. And with snapping, we have completely the same logic. But in addition, what we are doing is that we are orienting the held actor to match grab component's relative location. So again, first we attach parent to motion controller. It's the same logic as free grab. And afterwards, this logic is basically for snapping. We are then returning. So if it's held as false, we return false. But if it's true, we are setting the motion controller reference so our grab component actually knows which hand we're holding our cube with. Then we're calling the event so we could do some custom logic afterwards, and we are playing our haptic effect. And return is held to true. So going back to here, once tryGrab is successful, it means we have already grabbed the cube. And just to double check, we're checking if we're holding it. If we are setting our held component left to true. So we knew that we are holding something in our left hand. And here we have basically a check if we're holding item already. So this piece of code here is created for the cases when we are holding our cube, for instance, in our right hand, and at the same time we want to grab it with our left hand. So we need to clear out the reference for our previously held component in our right hand. Okay, let's go for our try release. So unstarted means that we have grabbed it, we performed this piece of code. But once we want to release it, we are checking if our held component left is valid, means that we are holding something in hand, and we are releasing this item. So let's go ahead in our grabs component try release function. And as you can see here, we're also switching our grab type, free or snap. And we're checking if it should simulate physics on drop. It is created for the cases to know if before grabbing our object, it was simulating physics. Because if it was, we need to simulate the physics after releasing. But if it wasn't, we don't simulate the physics. So let me quickly demonstrate you. Let's get this box over here and set its static mesh to simulate physics false. And this cube's mesh has simulate physics to true. And if I jump to the game, I'm scanning for the cube. And once it's scanned, you see it's green. And I got the grabs component parent, means the cube's mesh. And here, if I release, it doesn't simulate physics. But this one, remember, we set simulate physics to true. It means that before grab, it simulates physics. If I grab it, it stops simulating physics. And if I drop it, it simulates physics. But this one, if I grab it and I drop it, it doesn't simulate physics. So that's what this branch was responsible for. So afterwards, if it was simulating physics before grab, we just set simulate physics to true. So if you go in this function, we'll set simulate physics of the object, and it will automatically detach the component from our hand. That's why we don't use detach from component here. But in case of simulation physics set to false, that's where our cube was levitating, we are getting our parent, means we're getting our cube's static mesh, parent of grab component. And we're detaching it from our hand explicitly, keeping the world position. And afterwards, we just set is held to false. And then we return is held false and call event on drop. So here, that's the logic you can see. And if we release the item, we set our held component left to false. So now I hope you got everything about grab, and the same works for our grab right. I hope I explained it good. If you have any questions, you can still reach me out in Discord, in comments, everywhere you want, and I hope it really helped you. And also, as a bonus to this video, I'll talk about how pistols work. So let's go ahead in our pistols graph, and we're in our pistol blueprint. So as you remember, our grab component, when we grab or release, we are calling on grab, that's the event dispatcher, and we're calling on release, here, undropped. So on pistol, we use those event dispatchers, ungrabbed and undropped. So once we grab our gun, what we are doing is that we're looking for the hand that is holding the gun. So we are getting our grab component snap, it's here, and we are getting its hand. So if the hand is right, we are connecting our input mapping context weapon right. But if it's left, we're connecting our input mapping context left. And as you can see in our IMC weapon left and right, there is only one action, input action shoot right, and input action shoot left in IMC weapon left. That's the beauty of input mapping context here, because you can add inputs based on the condition you have. In our case, it's grabbing our gun, because we need to be able to shoot from the gun. And here we have our undropped. So that's the event you can find in try release. It's code right here. So this piece of code in our pistol will happen at this moment before returning. We are disabling the input and we are removing our mapping context that was added when we grabbed our gun right here. And here in the same gun, we are overriding those input actions. So for IMC weapon right, we have IA shoot right. And here we override it. And again, we're looking for what hand is holding the gun. And here's all the logic for our projectile. Okay, it comes to the end of our tutorial, and I hope I guys managed to help you in your understanding of VR template. And please leave a like and a comment under this video, and also subscribe to my channel, and I'll greatly appreciate it, and I wish everyone a good day.